right, let's continue on. Page 238. The procedure illustrated for calculating the formula mass of water molecule can be used to calculate the mass of any unit represented by a chemical formula. In each of the problems that follow, the atomic masses from the periodic table on the back of the book have been rounded to 2 decimal places, and that's what I want you to do. I want you to round to 2 decimal places. All right, so we're getting into our first example problem. Make sure that you have your sample problem paper out and ready to go. I've got mine. And do it exactly as it is shown in the book. So we're going to say I'm using a different pen for sample problems, number F. And what is the given? The given here is the formula KClO3. Okay, find the formula mass for potassium chlorate, KClO3. All right, and the unknown is formula mass. So the solution. The mass of the formula unit of KClO3 is found by summing the masses of 1 potassium atom, 1 chlorine atom, and 3 oxygen atoms. The required atomic masses can be found in the periodic table in the back of the book. In the calculation, each atomic mass has been rounded to 2 decimal places. Okay? So let's see if we can do that and look at our book at the same time. I think we can. So basically what they say is, okay, let's break it down. We've got 1 potassium, we've got 1 chlorine, and we've got 3 oxygen atoms. And it's treating it just like any other problem, so you're going to need a conversion factor. And we get our conversion factors from the book. So we've got 39.1 for every 1 potassium atom. We've got 35.45 for every 1 chlorine atom. And we've got 16.00 for every 1 oxygen atom. Okay? And so after that, basically, they get the numbers 39.1, 35.45, and 48. Why is it 48? Because they multiply times 3 times 16. And they add it up, and you get 122.55 AMU. Mr. Worley, this is totally simple. Wow. Why do we have to go through all those steps? Well, just to see how it works, we'll do the next one a bit quicker. Let's keep reading. So, we just learned how to find the formula mass of a formula, potassium chlorate. Let's move on. Oh, these look like great quiz questions. Can you do these? What about this one where it says calcium nitrate? Do we have 3 oxygens or 6 oxygens? I think you know that. Okay, let's keep reading about molar masses. Molar mass. Here's another thing you can write down. What is molar mass? Looks like a vocab word. In Chapter 3, you learn that the molar mass of a substance is equal to the mass in grams of 1 mole, or approximately 16.022 times 10 to the 23rd particles of the substance. For example, the molar mass of pure calcium is 40.08 grams per mole because 1 mole of calcium atoms has a mass of 40.08 grams. The molar mass of a compound is calculated by summing the masses of the elements present in 1 mole of the molecules of a formula unit that make up the compound. For example, 1 mole of water molecules contains exactly 2 moles of hydrogen atoms and 1 mole of oxygen atoms. Rounded to 2 decimal places, a mole of hydrogen atoms has, please go to the next page, and the next video, please. Thank you very much.